Hi there, everybody. My name is Edward, but I go by Teddy. Today we'll be talking about electric fields that vary with position, and then we'll have to calculate the movement and position of a charged particle that moves through this electric field. So let's start by saying we have an electric field with position 160 Newton per coulombs. Let's say we throw a particle from the origin that weighs 20 grams with a charge of 15 millicoulombs at an initial velocity of -5 to 0 meters per second. So the question we're going to ask is, what is the velocity of the particle 5 seconds later in its new position? So already going over what we know, the electric field's position, the mass, which we convert to kilograms for better unit conversion, and then we also convert the millicoulombs to coulombs by saying instead of 15 millicoulombs, it's 15 times 10 to the -6 coulombs. And we also know the initial velocity right here. So then using the force equation, which can be deducted that the multiplication of the charged particle, since we only have one, times the electric field, we get that 15 times 10 to the -6 coulombs times the position of the electric field, and then we get newtons as the coulombs cancel. Also, using that the change momentum is equal to force times the change of time, we have on one side of the equation momentum, which is just mass times velocity. And then we can determine velocity by subtracting the final minus the initial. So then the mass is just going to be the mass of the particle. We're trying to find the final velocity after the particle has moved through the 5 seconds. So then on this side of the equation, we just have the force right there, which we found up here, times the amount of time, 5 seconds. And then that comes out nicely here through calculations that our final velocity is going to be this vector quantity right here. And then we can average this velocity by adding the initial plus the final and dividing it by 2, and then adding that to where we initially started at the origin, and then getting that our final position is going to be this vector quantity right there. Now, since we have to deal with moving electric fields, we are gonna move the electric field to 310 Newton per coulombs. So then now we're gonna ask the same question: what is the position and velocity of the same particle after 5 seconds? So using this new electric field position with the same mass and charge of the particle, we still have, so our final velocity in the last particle situation after 5 seconds is going to be our new initial velocity. And so using that calculation, we just do the same force equation, and then we use the same change in momentum with the force times the time, and using the same setup as before, we plug in the mass and solve the mass, the initial velocity, force, and time, and we solve for the final velocity. Final velocity comes out to being this vector quantity right here. We average the two velocities as before, but this time we just used the initial velocity since it was that, and then we're gonna get that. And then we're not at the origin anymore, so we're just going to add it to our last final position, and then that's going to be our new final position for this equation. Thanks for watching. Leave a like.